Hello everyone, my name is just Dmitry. Welcome to the DPLABS channel. In this exciting episode, Alexander will talk about the creation of his innovative scooter. Please love and favor me. It all started when I got a mass-produced electric scooter. I really liked the idea of it as a mobile personal means of transportation, but in my opinion, the implementation was poor. In about a year of riding a Chinese electric scooter, I ended up replacing about 90% of its components. And that was just to meticulously keep it running and operational. During that considerable period of time, I managed to gain a truly decent and comprehensive understanding of the intricate subject matter and subsequently realized with clarity that virtually any other mass-produced scooter available on the market wouldn't be significantly much better in terms of overall quality or reliability than the particular one I already possessed. That's how I started developing a prototype of my own scooter, taking into account my preferences and relying on the experience I had gained. Initially, the idea was to keep everything fairly simple, using as many factory-made components as possible. But during the use of the first prototype, many of those parts ended up being replaced with homemade ones. In general, after a year of testing and riding it for over 16,000 kilometers, I gained an understanding of what not to do. A ton of experiments were conducted and many technical solutions were tested. It took several arduous months to meticulously invent, rigorously test, and precisely fine-tune the sophisticated active cooling systems. This extensive effort was necessary because, in the original design, individual heat exchangers were simply and directly attached to the main body with ordinary screws, utilizing only thermal paste. A lot of different options for the front suspension were tested. In the first version, it was impossible to go faster than 60 because of wobbling. I had to study in great detail exactly what trail is, the crucial caster angle, and precisely how each significant factor affects the others. Over time, this problem was solved without installing a steering damper while maintaining handling and comfort.
A lot. Very great deal indeed, truly.
A significant amount of work was done on the brakes. I initially started with a bicycle brake system. It turned out that their overall durability was far too low for this particular weight and speed. I couldn't get anything decent out of it. I had to design my own solution. That was a significant period of extensive experiments and valuable gaining experience. I successfully managed to try out many different solutions and acquire truly unique and specialized knowledge.
And in addition to that, further
then began developing a production scooter. The very first step was carefully selecting all the components. This particular time, the entire set of essential components was very thoughtfully selected and subsequently kept to an absolute minimum. And all the various little components like screws and essential crucial connectors. Next, I had to start designing the entire scooter structure from scratch. I truly wanted to work through every single detail and try to account for all the potential issues that had come up before, both during the initial assembly and in actual real-world use. A few weeks later, the first 3D model appeared. There was still a long way to go from the initial visualization to parts ready for manufacturing, since a lot of time was spent preparing and adjusting the Chinese machine for my needs during the production preparation stage. The actual production stage of version 2.0 took about 4 months and started with the motor. I designed the motor entirely by myself. The magnets and stator were manufactured according to my drawings, but by third parties. The motor housing is made of steel, 180 millimeters wide and with an outer diameter of 126 millimeters. These dimensions are determined by the mounting tires from a go-kart. I had to cut all the threads by hand. Fortunately, not a single tap was broken. The precise diameter for the bearing seat is exactly 25 millimeters. The very next crucial step was to meticulously manufacture the robust rear swing arm rails from a substantial 20 millimeter thick plate. The arms have channels for wiring and a well thought out reliable system for securing the motor axle. The axle is fixed in place using paired steel dropouts 5 millimeters thick. At the rear, it is securely clamped with a sturdy plate on two M8 bolts and firmly secured with 25 by 1.5 nuts. We meticulously wound the motor ourselves, carefully impregnating everything with several protective layers of varnish. In theory, when combined with its efficient cooling system, the hub motor should be able to reliably withstand a continuous load of approximately 12 kilowatts, with peak power outputs reaching up to 25 kilowatts. Along the way, throughout this entire process, we also had to meticulously perform some absolutely essential and critical operations, which were truly necessary for the successful completion of our objectives and the overall progress of the project. And sometimes this process took significantly more time than actually making a brand new part or assembling the entire scooter itself. For example, to carefully insert 150. An important feature of this scooter is its active liquid cooling system. The idea itself is truly simple. A specialized dielectric, thermally conductive liquid is carefully poured into the motor's interior, which effectively removes excess heat from the intricate windings. Powerful pumps then diligently circulate this heated liquid through an external radiator, and the now cooled liquid flows smoothly back into the motor for continuous operation. All the robust outer walls of the deck are strategically utilized for circulating the cooling liquid, and they are meticulously sealed tightly with a protective cover. The motor and the radiator are securely connected with durable hoses using precisely factory-made brass fittings. To prevent any potential coolant leaks inside the deck's sealed environment, the cover's tightness was rigorously tested at a significant pressure of 8 atmospheres. The whole structure was assembled using high-strength bolts, which turned out not to be the best idea. As it turned out, they rust quite badly. In future assemblies, durable stainless steel will be used. Thanks to the significant amount of time spent tuning the Chinese machine, the deck's geometry turned out perfect. To check the tightness of the entire assembled deck, coolant was circulated through the system with a pump for a whole day. No significant leaks were found, which ultimately means processing could continue. To ensure the protective covers fit perfectly, the precise mounting seats for them in the deck were carefully milled after assembly. Since the scooter only has rear-wheel drive, a robust go-kart tire was specifically chosen for its reliable traction, as it possesses the necessary properties and demonstrates low wear even under the loads experienced by a scooter. Plus, there's a pretty wide selection of tire manufacturers, so you can find something to suit any taste. Here, I'd like to make a brief digression about all-wheel drive scooters. I believe that with all-wheel drive, if there's a lot of power in the rear wheel, then during acceleration, the front wheel will get unloaded, and due to insufficient traction, simply won't contribute to acceleration. It seems odd to even discuss off-road capabilities on a scooter. With such small wheels, you'll get stuck in deep mud whether you have rear wheel or front wheel drive. A scooter is meant for good pavement. Let's get back to the assembly. To attach the titanium tubes in the scooter's construction, threads were cut into each end of the tube into which a threaded insert was screwed. The rear suspension is a multi-link design with 160 millimeters of travel. The choice in favor of a multi-link setup was driven by the need to position the shock absorbers horizontally while maintaining positive progression. The swing arm axles, made from 25 by 3 mm titanium tubing, are mounted on 4 SKF bearings. High-quality bushings, specifically manufactured from a durable and reliable graphite-filled Caprolon material, were carefully produced for the precise installation of the shock absorbers. During the manufacturing process, it is absolutely crucial to accurately take all necessary measurements directly on site to ensure a perfect fit and optimal performance. In some places, you need to select a clearance for an interference fit between the components. And of course, testing at every stage is essential to make sure everything moves properly within the intended range, with no play or unwanted extraneous noises. The battery, with a maximum voltage of 92.4 volts, consists of 22 individual prismatic cells carefully made by LG, each featuring an advanced NMC cathode and a substantial capacity of 60 ampere hours. With this particular battery, the maximum calculated speed was supposed to be 110 kilometers per hour. The robust steering shaft is meticulously crafted from high-quality steel, which has undergone a specialized chemical oxidation process. This particular treatment significantly enhances its durability and provides superior corrosion resistance. Furthermore, the mounting diameter, an equally vital component, is precisely engineered and constructed from a substantial 20 mm thick duralumin plate, ensuring optimal structural integrity and reliable performance. The front wheel disc assembly consists of two distinct halves, each precisely cut from a robust 50 mm thick plate. I had to make my own custom disc because I wanted to completely hide the protruding brake mechanism inside it. With such a very small front wheel diameter, the protruding brake disc constantly catches on everything and easily gets knocked out of alignment. I solved this problem in the following way. I wanted to talk a bit more about the speed and its weight. The advanced system was thoroughly tested in challenging mountainous terrain, where I personally drove extensively on numerous winding roads. The comprehensive test results, which were carefully observed and documented, proved to be truly amazing and highly impressive. The brake pads were used as the basis, and the brake shoes were cut from a 3 mm thick Soviet saw blade. I think they'll last forever. For compactness and reliability, it was decided to make the calipers floating and single piston. The rear brake is equipped with a primitive cooling system. The piston diameter was carefully selected so that locking the wheels only requires the gentle force of your index finger on the brake lever. Onboard computer, a useful thing for everyday situations. In this setup, even if the scooter flips over and falls on the handlebar, there will only be scratches. The case itself is sealed. Mechanical buttons, equipped with durable rubber seals, were specifically made for precise control. The cyclo itself is 4 millimeters thick. At the very beginning of testing the first version of the scooter, there was a problem finding a good throttle trigger to smoothly control the high power of the motor wheel. I ordered every possible option from AliExpress, spent a ton of time testing all of them, but eventually the time came. I realized it was easier to just make one myself. I picked a suitable bearing and went back to the first version. I rode it for the very first time, carefully figuring out precisely what not to do. And then, on the third comprehensive attempt, it turned out exceptionally well. I also conducted quite a few extensive experiments with the various headlights. Some of them were deadly. There were several options. The thoughtful combination of various solutions utilized in this project produced a pretty good result. I can confidently state that the scooter proved to be very dynamic and indeed exceptionally reliable in its overall performance. All the practical and hands-on tests will be thoroughly conducted in the second subsequent part of this video. We'll ride through the open fields, carefully check the maximum top speed, diligently test the brakes, and then try to go to an exciting electric transport meetup. I truly want to organize an exciting drag race with other enthusiastic scooter riders there, and then I plan to let a local extreme sports enthusiast thoroughly test the scooter's capabilities. Well, my dear folks, I sincerely hope you thoroughly enjoyed this presentation. Please leave your valuable comments, kindly give a big like, and make sure to subscribe to our channel. All the very best to you all.
Touch.